So let's look into Viterbi algorithm, which is the most common decoding algorithm. So it tries to find out the path or the state of sequences. It's a dynamic programming approach, and you guys are well familiar with that, so that's why I'm putting it here. So the objective is you are given a sequence of observations and HMM model. Now Viterbi can be used to find the most probable state path. So what we are given, the sequence of symbols x1 through n, and we find the paths which is given. So we have pi 1 through n, that is the path or the sequence of states, and which path we want. So we want the path that maximizes this thing, the maximum probability. So probability of observing a sequence over that path which gives us the maximum score or maximum probability. So we search recursively for the most probable state path by static, that is argmax over pi. So that is, we actually want to have the path, in simple way of saying this is that we just want the path that has the maximum probability of generating that sequence. So what we want to maximize, actually this is the whole probability of the sequence, we have seen that earlier. So actually we want a path that maximizes this whole thing, this whole probability of that sequence. Suppose the probability Vki of the most probable path ending in state k with observation I is known. So right now we are at I and the probability is known, and we want to move to the next symbol, so that is I plus 1. So far over here the state is k, and then we are moving into the next state L. So Vki is given by this equation. We are right now seeing over here is that the maximum path till that particular position. So Vki depends upon I minus 1. So right now we reach up till I while coming over a maximum path till I minus 1. So that is given by this relation over here, x1 through xi minus 1. The path was pi 1 through pi I minus 1. Right now we are in symbol xi, and right now our path is I, that is equal to k. So right now we are in state k while we are observing this symbol I. So that is what it is given to us. So that is actually the probability of most likely sequence of state ending at pi I, which is equal to k. Now we want to move ahead to the next place, to the next symbol, where we can have the next probability, which is given by VL. So symbol is xi plus 1, the probability is VL I plus 1. So we can then, in this equation we need to include the probability till pi I. So we flip around, play with these equations. We start putting their conditional probabilities, and then in the end here is the final equation where we can see the probability of that in which we observed for Vi, the previous symbol actually. So when you put it into that equation, finally we get through this relation, which is VL I plus 1, EL xi plus 1 is the emission probability of seeing that symbol over there while we are in this state L, and then we can multiply the maximum of moving till I position. So that part was, we reach at I, and now we are moving, or there is a transition from k to L over here. We're moving into next state, and where we can observe the sequence or observe the next symbol at that location, which is xi plus 1, which is right here. Same way for the ith position, we can use this equation. Right now we calculated, we started with I and then we moved to I plus 1. So if we are at I in the same relation, we can move back a further, and this Vk then becomes I minus 1 over here. So rest of the things they stay the same. Same way x I plus 1 becomes xi over here. So earlier what we have done is we were here and we were moving from here. So what about if you are interested at this place and you are right now here? So your probability up till that point can be calculated with this equation. So that equation is actually used in this Viterbi algorithm. So same steps, same stages. Since it's a dynamic programming algorithm, we have initialization, recursion, termination, and traceback. So we take the matrix, we initialize it with 0, and then there is a recursion where we put that equation which we have just explored right now, and then we keep pointers where we are getting those values from top to the bottom, or the way we did in dynamic programming algorithm. So that keeps track from where that value is coming in that particular cell. So when we reach in the end at the last state, so that is where our algorithm stops. So that is termination. So once we terminate that, then we move back while following our pointers and try to find out what was our maximum state path. So Viterbi algorithm is the most probable state path finding algorithm, or we can say is the decoding algorithm.